Hey, welcome back, Casibang's crew. This is the second video in Unit 5, Sensation and Perception. We are going to talk specifically about different types of visual perception today. I am going to go through this PowerPoint a little bit quickly. I do want you to take notes on your video guide, and I do want you to draw pictures to help you remember these different types of perceptual principles. So the first thing that we're going to talk about is that there are three different types of perceptual principles that we're going to talk about. We're going to talk about gestalt principles, then we're going to talk about depth perception, and then we're going to talk about some constancies. So you'll notice in your notes there's a big chart there. I want you to just sort of describe what they are and then draw yourself just a small little picture so that you remember them. So first we're going to talk about the gestalt principles. So the gestalt it was a psychologist that talked about our experience, our perception, being able to come from organizing information into something that is meaningful to us. So most of these gestalt principles are going to be around sort of organizing information. So the first one is proximity. So this one says that we group items together just because of their closeness. So for example, if you look at the image in A, we look at this as 3 sets of lines instead of 6 separate lines, because these lines, and these lines are close together. Okay? They're in proximity to one another. Okay, and then the second one is similarity. So we think of similar objects as belonging to each other. So again, when we look at image B, we see this as rows of X's and rows of O's, right? Instead of a row of XO, 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 we see them as singular columns. That's that similarity. Okay, this image, I'm going to talk about this in a second. Okay, so this is number 3. Okay, that is the idea of continuity. We want to see smooth, continuous patterns. So like that image before us, we saw it as 2 separate lines. Okay, so we want to see smooth, continuous patterns, lines and waves, not disrupted ones. So again, in this image, we see it as 1 line and a wave. Okay, we don't want to see it as a bunch of half circles. See the half circles there? Okay, so that's continuity. Okay, here's our little runners. Okay, there they go. Keep going. All right, so common fate. This is the idea of common fate. We think things that move together belong together. Okay, so just like our 2 little runners there. Okay, what is in this image? What do you see? You are using the gestalt principle of closure. We perceive a complete image even when our senses are missing information. Our brain just fills in the rest of the information. So here you see a dog. And in the second picture, is that going to pop up? You saw an elephant. Okay. Okay, here you saw a person walking. All right, number 6. Okay, we talked about this in the last video. It's figure ground perception. So the perception of figures against a background. So here's the vases and faces image again. So here we see the faces and the white we see as a vase. Okay, so this is the figure ground. So we are seeing figures, okay, against a background. And actually, it could go either way. The vase could be the figure and the background could be the faces. Okay, so here's figure background as well. Okay, so you notice that when we grade it out. Okay. Good images for you there. All right, motion, ideas of motion. This is not necessarily gestalt, but I put it in there in the chart. So this idea of stroboscopic motion. So this is the perception of movement from the rapid progression of images. So if you guys have ever had like a flip book, or if you've ever taken a book of Post-it notes and made a flip book, you have used stroboscopic motion. Okay, so here's a really cool one. Hey, Michael Jackson, that someone made. So as you flip through it, it looks like he's dancing, but really each individual page has a separate picture on it. They're really cool, aren't they? Takes a lot of time to do this. Pretty cool. Okay, so now moving on to depth perception. So the first thing that I want you to note is that there are two different ways that we see depth perception. We see them first through monocular cues and second through binocular cues. So monocular, one, okay? So this is one of our eyes, and then binocular is two. So we're going to start with the monocular cues first. Okay, so like I said, monocular cue, you only need one eye to perceive depth. Okay, so there's a bunch of different monocular cues that we're going to talk about here. Okay, that's called the Ponzo illusion. Okay, so the Ponzo illusion is an illusion, or a monocular cue, I'm sorry, of perspective. Okay, perspective. Here's another one. Okay, so it looks like they are two different sizes. The yellow lines are two different sizes because of the train tracks, but really when you isolate them, you see that they are in fact the same size. The second monocular cue is clearness. Okay, how clear we see the picture indicates to us how far or close it is. Okay, so in this image, this looks like it's real close to us, and because this is kind of like grayed out or not as bright, we perceive it as being further away. Overlap, okay, overlapping is a monocular cue as well. Okay, so if we look at these guys, okay, we know, or we think because of the overlap, we think that our orange circle is in front of the green circle because of overlap. Okay, so again, in this image, you see there's some overlap in the trees. So here we perceive this tree right here as being in front of these trees in the back because of the overlap that we see there. Okay, same with this picture. Okay, shadow and then gradient texture. Those are our last two. So let me put this image on here. Okay, so again, you can see a little bit of texture, maybe a little bit of shadowing in here that make the two balls look different. Okay, here's an image for you as well. What direction is this ball heading in? Okay, by looking at the shadow that's underneath the ball, you see here, the shadow, it makes us think it is going all in one direction. Okay, but there our shadow, and the second one is traveling diagonally. Okay, here's an image of a gradient texture. Okay, so again, we perceive how things are either close to us or far away based on the texture in the images. Okay, so these we see as separate, these dots we see as separate and closer to us, and as they get further away, they're a lot smaller and they're a lot closer. Okay, so that idea of the texture of an image, or sort of like geometric designs, can help with our depth perception cues as well. Okay, and the last one is motion parallax. If you've ever been on a road trip and, you know, looked out your window, this looks super close to us and it looks like it's kind of going quickly, and the thing all the way in the back, like on the other side of this river, looks like it's not going as quickly. Right? So again, that's showing us that depth perception, or giving us that idea of depth perception. And then our binocular cues. So the two binocular cues that we talk about are retinal disparity and convergence. So retinal disparity is kind of cool. So we have two eyes and they're roughly 2 inches apart. So each eye views the same image slightly differently just because of where it's placed on our head. So our brain, because it is so cool, okay, combines that image for us into one stationary image. So if you see here, our left eye sees it kind of like this, these bowling pins. Our right eye sort of sees it like this. And then our brain puts the image together into one image for us. Now, the closer you are to an object, the harder it is for your brain to put the two images together. And we're going to kind of play with this retinal disparity a little bit in class tomorrow so that I can show you how that happens. The second binocular cue is convergence. And this is really like your muscles are doing this for you. So as you are focusing on an object that is very close to your face, your eyes move in closer to each other. And this is automatic. This is not something that you have to think about doing. This is something that our eyes and our brains automatically do for us when we are trying to focus on something that's very, very up close to our face. All right, so the last thing that we're going to talk about are the perceptual constancies. And I think these are probably the easiest ones to remember because they're named super basically. So our perceptual constancies are perceiving objects as unchanging even as our light and the images change. Okay, so the first one is color constancy. So we perceive objects as keeping their color even though different light changes the appearance of their color. Okay, so different light can make this look slightly different. Okay, so if we zoom in on that a little bit, it does look a little bit darker in this area, but when we saw the shirt as one whole, we left it all as one color. Okay, so this image here, okay, so we have a box or a cube, okay? The top part of the cube has like a blue background, like the sky. The bottom image of the cube has more like of a grass or a dirt image. And in this image, what colors are the cubes? Okay? I see gray up top and I see white on the bottom. But once you take the background away, okay, you're able to see that they're actually both gray. Okay, I'm going to take it away completely.
Alright, so the world has seemingly become utterly divided on this dress. What colors do you see? On the one hand, we have team black and blue. On the other, team white and gold. We asked on Twitter and got hundreds of responses for both white and gold and black and blue. For what it's worth, we both saw black and blue and thought this was a massive prank at first. So how can it be possible for people to see it so differently? It's a phenomenon known as color constancy. Take this cube, for example. The middle square on the top appears to be a shade of brown, while the one on the side looks much more orange. But in actuality, they're both the exact same color. We promise we haven't cheated here or done any trick photography. Instead, our brain looks at the context, sees a shadow, and instantly thinks, oh, shadows make objects appear darker. And so the brain compensates and interprets the square as lighter than it appears, until the shadow is taken away. Back to the dress, and we have a similar situation, except here the context is very arbitrary. We're so close up to the dress that we don't really know its surroundings, and the brain has to make assumptions. People who picture the dress as white have brains which may be interpreting the dress in a blue lit room, for example, as in it's near a window with a bright blue sky. It makes perfect sense then that the white dress would be tinted blue and that the gold color wouldn't really change. On the other hand, the brains of people who see it as black and blue may be interpreting the dress in an artificially lit setting like somewhere with yellow lights. As a result, the brain sees the gold as just a reflection off of the black and believes that the blue has been unaffected. Chances are that this image just happens to be perfectly ambiguous to our brain, meaning it all comes down to individual perception and even how and where you view the image. From a factual standpoint, the dress is blue. In fact, here are some other pictures of it, but this is a beautiful example of how our brains have evolved to interpret the world around us without us even realizing.
Okay, who remembers that dress controversy? All right, so the second constancy is size constancy. So we see objects as having a constant size even while our distance away from them varies. So we know that this image in the background, this football player, is a similar size to this one here because we can see the depth there. And then shape constancy, perceiving objects having only one shape no matter what angle you view it at. So for example, this tire, okay, we know that the tire is round even though we're looking at it from two different angles. Okay, so when we put the circle on it, okay, you see that it's actually a circle and more of an oval shape. There you go, see? All right, and brightness constancy, okay, and that was talked about in that little video clip as well with the dress. So our tendency to see an object equally bright even though the intensity of light around it changes, okay, so this example here, okay. So when that is taken away, you notice that the A and the B square are actually the same color. Okay, and then the last one for the perceptual constancies is the Mueller-Lyer illusion. Two lines of the same length appear to be of different lengths. This works because of size constancy. And really, interestingly enough, it doesn't work in all places in the world. It doesn't work in all cultures. But if you look at these two lines, this line here and this line here are really the same size, but because of the arrows or the way the arrows are going on here, they appear as if they're two completely different sizes. So when you look at it in terms of a house, okay, an interior corner and an exterior corner on a house, again, they are the same size. So this is why it doesn't work in all cultures. So in some cultures, you don't have right angle buildings and houses. Sometimes you have more like softer curves or circular buildings. So this illusion doesn't work as well in those type of cultures. Alrighty, so that is it for this one. The next video that we will talk about will be the eye. We'll diagram the eye and we will talk about how we perceive vision. Don't forget, write down any of your questions and come to class with them tomorrow. Bye-bye.